Okay, we have 2e to the negative t power for x, and we have e to the negative 2t power for y. T has to be greater than or equal to 0, so we're going to start at 0 and then increment upwards. So we're not going to go to infinity, obviously, so we'll just stop when we run out of boxes. Now, e is a number 2.71 or something like that, but it's in your calculator, so don't worry about exactly what it is. So e to the 0 power would be 1, right? So 2 times 1 would be 2. And then this one, e to the 0 power, would be 1. Okay, so then you've got the next ones, Adrian, you plugged them in. So then we've got 2e to the negative 1, which is 0.73. And we've got e to the negative 2, which is 0.14. And then we have 2e to the negative 2 and e to the negative 4. Oh, okay. Yeah. Okay. So would you say that as time goes to infinity, that our path will approach an asymptote of sorts? Maybe. Oh, I'm looking at my picture from last year. This is very interesting. Okay. So e to the negative 3 is 0.1. And then 2e to the negative 6 is 0.002, right? Okay, and then 2e to the negative 4 is like 0.04. And then 2e to the negative 8 is 0.0003. All right. Looks like we don't need to go lower than 0. Like all of these numbers are positive, so all we need is quadrant 1. And again, I feel like I'm going to count by 4s. Well, not count by 4s, but each one value will be 4 squares just to accommodate some of these smaller numbers. So 1, 2, 1, 2, that way. Okay, let's graph our points and see what's happening. So we're going to have a point at 2, 1. That's our starting point. We're going to have a point at 0.73, 0.14, so I don't know exactly where that is, but it's going to be lower than 0.25 and lower than 0.75, but really close. Then 0.27 would just be past one of the little quarter marks here. And then, I'm sorry, I know I'm in the middle of this, but I think all right, so then we have a point at 0.27, 0.02, we have a point at 0.1, 0.002, 0.4. Anyway, we are getting closer and closer to the origin, but we are never getting to the origin. We're just getting closer to it, but never getting there. Like an asymptote, but instead of an asymptote, it's like a hole that we never get to. Interesting. It's like the object just slows down and keeps moving forever, but never gets there. I don't know. That's what I was just thinking in my head. I was like, is that like a black hole or something?